We're here today to talk about the importance of tracking batch overruns and equipment downtimes in your operation. And from there, we want to talk about an approach to tracking using best practices and a commercial solution that leverages your investment in OSIsoft Pi. What are some of the business challenges that you're facing today in your operations? These are some of the common business challenges we see when we're working with our clients. How do you justify your capital or operational investment budgets? How do you ensure that my KPIs are accurate and timely? Do I have the data that I need to quantify my continuous improvement projects? How do I identify and improve equipment utilization? How do I reduce my operators' non-value added work? What are the business impacts of my challenges? If I have the proper data, I can use this data to help me reduce my overruns and downtimes. Understanding my top offending overruns and downtimes, I can eliminate the root cause of my production inefficiencies, as well as allow me to reduce my capital requirements. How do I make better use of my inputs for production? Increasing my production efficiency will result in better financial results. What are some of the best practices when it comes to tracking overruns and downtimes? It's very important to have a standardized approach to data capture, making sure your reason codes are well defined and meaningful, as well as your time usage model. What KPIs do you need to manage your operation? Make sure that they're well defined and standardized across your operation. Overruns and downtime tracking needs to be implemented as a solution, making sure to use recommended best practices. RtTech has developed a downtime and overrun tracking software solution called RtDUET. The solution runs on top of OSIsoft Pi. One question we hear from prospective clients is, why do I need to purchase a commercial solution? Can I just build my own? We feel that there are a number of reasons you would want to consider a commercial solution over a homegrown solution. Our solution is professionally developed and maintained and has been available since 2003. The driving force behind the software's growth over these years has been our clients and their experiences. The software is continually updated in new features as well as keeping current with OSIsoft Pi. We typically have a yearly major feature release primarily driven by feature requests from our clients. We have a dedicated support team that is available to provide technical support and assistance to our clients, and our solution allows for a rapid deployment that will result in quicker return on investment than if you were tried to build your own solution. What RtDUET will allow you to do is take your plant data, like you see in the screenshot on the left, and generate event frames that you can now add additional context around using the RtDUET web interface. This is a high-level diagram of the architecture of RtDUET and how we sit in relation to OSIsoft Pi and SQL Server. As you can see at the bottom of the screen, we have the field devices, PLCs, and sensors. These are connected through interfaces to OSIsoft Pi. RtDUET doesn't connect directly to any sensors. We let Pi look after that. RtDUET sits on top of Pi. Actually, the backend for RtDUET is OSIsoft AF. We have 6 components that get installed with RtDUET. The red ones are Windows services and run in the background. The light blue one is the web API used for third-party integration. And the 2 green ones are applications that would be used by an operator or user. The calculation engine is a service that is continually looking at Pi tags and using trigger logic to determine if something is in an overrun or downtime state. The KPI engine uses all the events that were created by the calc engine and generates all your KPI numbers. We produce 16 KPIs right out of the box, but can configure the system to produce pretty much any custom KPI. The data sync engine takes all the RtDUET data that is stored in AF and syncs it out to SQL Server database in real time. The web API is a REST API that can be used by third-party applications to interact with RtDUET. The toolkit is the application used to configure the system, such as the reason tree, time usage model, and triggers. And the web interface is the primary interface used by the majority of the users. It's where you would do all your event maintenance as well as visualize your KPIs. Then we see that RtDUET is synced to SQL Server, where you can use reporting tools such as Power BI, Tableau, or Excel to report on this data and possibly combine the RtDUET data with your other systems such as an ERP. Now I'll take you through some of the main features of RtDUET. The main operator interface for acknowledging and coding events is the event page. It allows the operator to easily identify new events and proceed to apply context to them using a standardized tree of reason codes. The associated time usage model allows you to classify each of the reason codes into a delay type, facilitating the generation of standard KPIs such as availability, utilization, operating efficiency, and more. Leveraging the power of OSIsoft Pi and event frames allows for the application of custom attributes to your events, giving you more context and the ability to further analyze the events. Lastly, the ease of data export allows you to interface the RtDUET data with other reporting platforms to generate advanced analytics and business intelligence. Let's explore each of these features in greater detail. Here we see an example of a reason code tree on the left and the corresponding time usage model on the right. The reason code tree is pre-configured to ensure a standard list of reasons are defined for the operator so as to ensure consistency between users. This eliminates the broken gearbox and gearbox broken type of reasons from appearing in your reports. The reason code tree is customizable, but usually arranged in a logical format similar to the site layout to allow the operator to choose which asset or area caused the event to occur. As the operator chooses the reason code on the left, the corresponding time usage code is automatically selected. This means your operators don't need to worry about picking which category the downtime should be placed in. These time usage codes are then used to generate the standard KPIs of your assets. Since RtDUET sits on the top of OSIsoft Pi, we can leverage the power of Pi to gain more functionality out of RtDUET. Custom attributes allow for greater context to be applied to the event by including other data from your Pi system. When reporting or analyzing the data, the custom attributes enable you to further slice and dice the data to reveal true root causes of your overruns. Imagine answering questions such as, what products are causing longer changeover times? What product specs generate the most operational delays? What is the cost impact of my batch overruns? By including custom attributes from the Pi system into your events, you can begin to start answering these questions. RtDUET can also take advantage of your Pi system data by using Pi tags to auto-code your events. Through a series of logic statements, RtDUET can preload the reason code into the event frame if the data is available in Pi. This can significantly reduce the time and effort required to classify downtime events by your operators. Here is an example of the RtDUET event page. This is the primary user interface for the operators to identify and classify events. Across the top, you'll find the date time modifier as well as a trend showing when the overrun and downtime events have occurred. Below, we have the events table. The various colors represent the different stages of validation. If desired, a validation process can be implemented, allowing events to be edited by the operator and then validated by a supervisor. You'll see here the system automatically captures the start and end time of the event and calculates the duration. The reason and time usage code are either manually entered or auto-classified. Here we have a little animation to visualize the event capture process. We have a process running, and then our Pi tag indicates the batch step has been running longer than expected. The system records the beginning of the overrun time. Once the Pi tag indicates the batch step has been completed, and the end of the overrun time is recorded, and the event is closed. This triggers the event to appear in the RtDUET events page and allows the operator to classify it. Here we see that the operator proceeding to classify the event. First, they find the event in question and select the Edit button. They can also just double-click on the row as well. This pops up the Edit window where the operator can start drilling down through the reason code tree to arrive at the appropriate classification. As you can see, once they selected the reason code on the left, the time usage code on the right is automatically selected for them. Once the Save button is clicked, the event window closes and reveals the reason code and time usage code applied to the event in the events page. You'll also notice the row turn blue, indicating the event has been edited. Custom attributes are automatically calculated and included without any interaction from the operator. Finally, we just wanted to touch on how easy the data in RtDUET can be exported to another program for advanced analytics or reporting. All the data generated by RtDUET is being stored in Microsoft SQL Server tables. So any application that can interface with Microsoft SQL Server can easily grab this data. As well, since RtDUET is fully integrated with the OSIsoft Pi system, we can leverage the Pi user tools to analyze or display RtDUET data as well. This includes Pi Asset Framework, Data Link, Pi Vision, and Process Book. The slide shows the capture of event data within Excel and a resulting pivot table report that provides analysis of the offending downtime events. As mentioned earlier, RtDUET is best implemented through a solution approach, meaning we don't simply drop off the application and hope you figure out how to use it. We take a four-step process to implementation. We start with an upfront workshop to understand your specific requirements, define the time usage model in our KPIs, build out the reason code tree, and define any custom reporting requirements. Based on the resulting configuration document, either remotely or on-site, we perform the system installation and configuration. Finally, we'll come to site and perform a training session with the users who will be classifying events as well as extracting the data and performing the analysis. Additionally, 3 to 6 months after implementation, we facilitate a workshop to help analyze the data and identify some of the low-hanging fruit opportunities for asset improvement. As well, we will work with you to further refine the solution based on feedback from end users since implementation. Now I'd like to wrap things up and quickly summarize the benefits and advantages of using RtDUET for your overrun and downtime tracking and for the generation of your KPIs. Our solution is built on top of OSIsoft Pi, so the data you're seeing is real time. RtDUET brings significant business benefits by allowing you to tackle your business challenges. Our solution approach allows for a structured implementation and a rapid payback. You will start seeing your overrun and downtime events as soon as the system is started. The data that we collect around the events gives you visibility into your processes and allows you to use business intelligence to improve these processes. Because we're tied to OSIsoft, the data in RtDUET is accurate and your downtimes can be tracked to the second. As we mentioned earlier, we take a solution approach to implementing RtDUET. We don't just hand you the software and let you figure it out. We will work with you every step of the way through the implementation. I know we've said this a few times, but we feel one of our biggest advantages is that we leverage the power of Pi and we provide you with more value for your investment in the Pi system. RtDUET is a professional software solution. We have a dedicated support team to assist our customers when they need it, as well as a dedicated development team that is continuing to advance the product forward. We also work with local integrators who can provide subject matter experts and integration services closer to your location. Please visit our partners page to find integrators that could help your implementation of RtDUET. Also, please contact RtDUET Software if you would like to explore further how RtDUET can be used to further your business goals.